Students, in the field of chemical production, the precise measurement of various process parameters plays a decisive role throughout the entire production process. Any deviation in measurement may lead to a decline in product quality, reduced production efficiency, or even trigger serious safety accidents. Therefore, mastering the knowledge of chemical measurement instruments is an essential skill for our future careers in the chemical industry. Today, we will delve into the related content of 6.3 Chemical Measurement Instruments. In chemical production, there are 4 common types of measurement instruments: temperature measurement instruments, pressure measurement instruments, level measurement instruments, and flow measurement instruments. First, temperature measurement. Temperature reflects the degree of heat or cold of a material, and in chemical production, accurately controlling temperature is crucial for the progress of chemical reactions. The commonly used temperature scales are the Celsius scale, the Kelvin scale, and the Fahrenheit scale. The Celsius scale sets the temperature of an ice-water mixture at standard atmospheric pressure as 0 degrees Celsius and the boiling point of water as 100 degrees Celsius, with the interval divided into 100 equal parts. The symbol for this temperature scale using degree Celsius as the unit is T. For example, in ammonia synthesis, the reaction temperature inside the synthesis tower is typically controlled at around 400 to 500 degrees Celsius, and this temperature is expressed using the Celsius scale. The Kelvin scale defines the temperature at which molecular motion ceases as absolute zero, i.e., 0 K. In certain low temperature chemical processes, such as air separation for producing liquid nitrogen and liquid oxygen, the Kelvin scale is used. For instance, the boiling point of liquid nitrogen is 77.35 K. Under standard atmospheric pressure, the Fahrenheit scale sets the freezing point of water at 32 degrees Fahrenheit and the boiling point at 212 degrees Fahrenheit, dividing the interval into 180 equal parts. The Fahrenheit scale may appear in the parameter markings of some imported chemical equipment. These 3 temperature scales can be converted between each other. The conversion is such that the Fahrenheit temperature equals 9/5 times the Celsius temperature, plus 32. The Kelvin temperature equals the Celsius temperature, plus 273.15. For example, water at standard atmospheric pressure freezes at 0 degrees Celsius, which converts to 32 degrees Fahrenheit and 273.15 K. Let's do an exercise. Convert between the following units. Did you get it right? Next, we will study some common types of temperature measurement instruments, which mainly include the following types. First, mechanical temperature measurement instruments. In laboratories, we often see mercury thermometers and alcohol-filled thermometers. These are examples of liquid expansion thermometers. In experiments for determining the melting and boiling points of chemical reagents, mercury thermometers play an important role. By precisely measuring the temperature changes during heating or cooling, their measuring principle is based on indicating the temperature value according to the change in volume. Expansion spring tube thermometers are widely used in measuring the temperature of steam boilers. Its principle is that temperature changes are transmitted through a measuring tube, causing the spring tube to bend and thereby indicating the temperature value. This thermometer has a range from -200 to 800 degrees Celsius. The measurement principle of a bimetallic thermometer is that two different metals have different coefficients of thermal expansion, and the degree of bending of the bimetallic strip corresponds to the temperature. In industrial ovens, it can be used to control temperature. When the temperature is too high, the bimetallic strip bends. To actuate a switch that cuts off the heating power, and when the temperature is too low, the strip returns to its original state. To reconnect the power for further heating. Second, electrical output, temperature measurement instruments, resistance temperature detectors, RTDs, are common in measuring the temperature of pipelines in the petrochemical industry. Their measurement principle is that the resistance of a specialized metal coil changes proportionally with temperature. For example, on an oil pipeline, a PT100 RTD is installed. By measuring the change in resistance, the temperature of the crude oil can be monitored in real time, allowing for timely adjustments to the transportation process. Thermocouple temperature detectors are indispensable in measuring high temperatures in metallurgical furnaces. For example, in a steelmaking furnace where temperatures exceed 1000 degrees Celsius, thermocouples can quickly and accurately measure such high temperatures and transmit the thermoelectric potential signals to the control system. Their principle is that when two conductors of different materials form a closed circuit with junctions at different temperatures, a thermoelectric potential is generated in the circuit, from which the temperature difference can be deduced based on the magnitude of the potential. Thermocouples range of thermocouples spans from -180 degrees Celsius to 1800 degrees Celsius. In the glass manufacturing industry, where precise control of furnace temperature is required, infrared thermometers can quickly measure the surface temperature of the furnace without contact, allowing operators to adjust the heating power in a timely manner. The measurement principle is based on measuring the infrared energy radiated by the object to determine its surface temperature. The temperature range of infrared thermometers spans from -50 degrees Celsius to 3000 degrees Celsius. Second, pressure measurement. Pressure is ubiquitous in chemical production. For example, in high-pressure reactors, reactants need to undergo reactions under specific pressure conditions. Pressure is defined as the force acting perpendicularly and uniformly on a unit area, as shown in the figure, with units of newtons per square meter, also known as Pascal. In practical applications, we also use units such as kilopascal, megapascal, and bar. For example, in inflating car tires, the pressure is typically around 2 to 3 bar, which converts to approximately 200 to 300 kilopascal. In expressing pressure, atmospheric pressure is the basic pressure in our environment. But in chemical production, we are more concerned with absolute pressure, relative pressure or gauge pressure, and vacuum degree. During vacuum distillation, it is necessary to precisely measure the system's vacuum degree. To ensure the smooth progress of the distillation process, we need to focus on the definitions of these pressures and the relationships between them. Atmospheric pressure is the pressure exerted on objects by the weight of the atmosphere. Absolute pressure represents the actual pressure experienced by an object. Relative pressure is the pressure expressed relative to atmospheric pressure. Vacuum degree, also known as negative pressure, refers to the extent to which the gas is rarefied under vacuum conditions. As shown in the diagram, the difference between two pressures is called the differential pressure. When the absolute pressure exceeds atmospheric pressure, the difference P is the gauge pressure. When the absolute pressure is lower than atmospheric pressure, the difference PV represents the vacuum degree. Next, let us study some common pressure measurement instruments, whose main functions include indicating, recording, alarming, remote transmission, and control. They mainly include the following types. 1. Liquid column manometers. In laboratories, liquid column manometers are often used to measure relatively low pressures, such as the slight pressure variations of gases in a pipeline. Their measurement principle is based on fluid statics. 2. Elastic pressure gauges are widely used in factory compressed air systems. They can intuitively display the pressure of the compressed air, facilitating operators in monitoring equipment status. Their principle is that the sensitive element, such as a spring tube, diaphragm case, or bellows, inside the gauge deforms elastically under pressure, and then a conversion mechanism transmits this deformation to a pointer to display the pressure. 3. Electronic pressure gauges. On highly automated chemical production lines, electronic pressure gauges play an important role. Their measurement principle is that the displacement of the elastic element, when subjected to pressure, is converted into an electrical signal corresponding to that pressure. For example, in natural gas pipelines, an electronic pressure gauge converts the pressure signal into an electrical signal, transmits it to a remote control system, and if abnormal pressure is detected, the system immediately issues an alarm and takes corresponding measures. Third, level measurement. Level measurement is widely applied in chemical production, involving various storage tanks, reactors, and other equipment. For example, in crude oil storage tanks, accurately measuring the liquid level helps calculate the stored volume of oil, thereby facilitating reasonable production and transportation planning. In oil-water separation tanks at refineries, it is necessary to precisely measure the interface between oil and water to ensure effective separation and improve oil quality. Level refers to the position and height of material within a container or industrial equipment, including liquid level, interface level, and material level. Level is often expressed in units of length or as a percentage. The purposes of measurement include determining the volume or weight of the substance in a container, monitoring the level inside the container, and continuously monitoring production for regulation. Next, let us study some common level measurement instruments. In some small-scale chemical workshops with atmospheric storage tanks, gas tube level gauges are often seen. In the storage areas of large petrochemical enterprises, differential pressure level gauges are more commonly used. In sedimentation tanks at sewage treatment plants, magnetic flux level gauges can display the liquid level in real time. They mainly include the following types. 1. Direct reading level gauges. Their measurement principle is based on the communicating vessels principle. They are suitable for on-site level measurement where the pressure is not high. In some small-scale chemical workshops with atmospheric storage tanks, glass tube or plate level gauges are often seen, from which operators can directly read the liquid level. 2. Differential pressure level gauges. Their measurement principle is based on fluid statics. They can be used for measuring the level in open or sealed containers. In the storage areas of large petrochemical enterprises, differential pressure level gauges are widely used, as they can precisely measure the liquid level in sealed tanks. 3. Buoyancy type level gauges. Their measurement principle is based on force equilibrium. Examples such as magnetic float level gauges and flow ball level gauges are commonly used for measuring the liquid level in tanks. Frost type level gauges can continuously measure the level or interface in open or sealed containers, and are used for remote display and control of the level when needed. In sedimentation tanks, at sewage treatment plants, magnetic float level gauges can display the liquid level in real time. When the level reaches the upper or lower limit, an alarm is triggered to alert the staff for timely action. 4th, flow measurement. Flow is the amount of fluid that passes through a given section of a pipe or equipment in a unit of time. It is an important parameter for gauging the flow condition of fluid in types or equipment. In chemical production, precise control over the flow of raw materials and products directly affects production quality and efficiency. For example, in the pharmaceutical industry, the flow of various raw materials during drug production must be strictly controlled according to the formulation. To ensure consistent product quality, flow is divided into volumetric flow and mass flow, with common units for volumetric flow being cubic meters per hour, liters per hour, and for mass flow being tons per hour and kilograms per hour. In water treatment plants, the water supply is calculated by measuring the volumetric flow of water. In petrochemical enterprises, the transportation of crude oil focuses more on mass flow to accurately gauge product output. Next, let us study some common flow measurement instruments. They mainly include the following types. 1. Rotor flowmeters. They belong to the category of velocity type flowmeters. The measurement principle is based on measuring flow through a constant pressure drop and the variable throttling area. In small-scale chemical experimental setups, rotor flowmeters are widely used for measuring the flow of gases or liquids due to their simple structure and low cost. 2. Elliptical gear flowmeters. They are a type of volumetric flowmeter. Their measurement principle is that a mechanical measuring element continuously divides the fluid into discrete portions of known volume, and the total volume is determined by counting the number of filling and emptying cycles. They are suitable for measuring clean, particle-free, high temperature, and high viscosity liquid media, offering high accuracy and strong reliability. In the food and beverage industry, elliptical gear flowmeters are commonly used to measure the flow of high viscosity liquids like syrups enabling precise control of ingredient proportions. 3. Coriolis or Coriolis flowmeters. They are classified as mass flowmeters. Their measurement principle is that as the fluid flows through a vibrating tube, a Coriolis force proportional to the mass flow is generated, and by measuring this force, the mass flow can be determined. They offer high accuracy and a wide measurement range and can be used to measure slurries containing solids, liquids with trace gases, and medium to high pressure gases, and are especially suitable for measuring the mass flow of high viscosity or even difficult to flow liquids. At natural gas metering stations, Coriolis mass flowmeters can accurately measure the mass flow of natural gas, providing reliable data for trade settlements. Class summary. Today, we have systematically studied the measurement techniques for temperature, pressure, level, and flow in chemical production, gaining an understanding of the different temperature scales, pressure, representation methods, and the concepts of level and flow, as well as the various measurement instruments corresponding to them. Through practical examples, you should now have a more intuitive understanding of these concepts. I hope that after class, you will review these materials diligently to deepen your understanding. You may also consult additional resources to learn about other new types of chemical measurement instruments beyond those introduced in class, and to understand their working principles and application fields.